I can change with this. Okay. Good afternoon to everybody. First of all, I want to pay my thanks to the organizer, the Ferrocement Society of India and Bnca, the college, for giving me the opportunity to present here. So I must say, actually, I am here because of I am the life member of Ferrocement Society India. So I am very much grateful, though I am not Indian citizen, but Indian Ferrocement Society generous to uh, give the membership, life membership. So I am very much thankful to the Ferrocement Society of India. And to be very frank, I am working for the last 15-20 years with Ferrocement, but what I have learned in 15 years, but much more I learned in last 5 years after having in contact with Ferrocement Society of India. So, and from my experience, I can request all of you who is not yet the member of the Ferrocement Society of India. Actually, I am also the member of the International Ferrocement Society, but that is not active, that is almost dead. So, whole world is now led by the Ferrocement Society of India. So, that is why actually the especially who is in Pune should not miss this opportunity to be a member of the Ferrocement Society of India. So thank you, and I must say the Ferrocement Society of India made me the opportunity to be here in Bnca College. Actually, it was not known to me that there is a college of architecture for women only in Pune, and I must say it's a very appreciating, because both are equally important. The subject ferrocement, introduction of ferrocement technology, as well as the women empowerment. I think this BNCA is for women, architecture for women. Will, I think play a positive role for women empowerment. So now, just 1 minute before I start my presentation, I want to. It's not. Slide not changing.
टीमची सेटिंग कुठे आहे मॅडम? टीमची सेटिंग टीमची सेटिंग कुठे आहे? टीमची सेटिंग चालू आहे व्यवस्थित.
शेअर करून कशाला सगळं करताय ते?
सुहासला बोलून घ्या ना मॅडम. सुहास.
हॅलो,
हां सर.
आवाज येतोय का?
हो येतोय.
हा मला तुमचा आवाज येतोय.
नाही पण अच्छा ठीक आहे,
सर.
आता येतोय आवाज. हो हो
हॅलो.
हो हो, विनायकचा येतोय. हो
येतोय सर.
हो, येतोय येतोय.
ओके, ठीक आहे सर.
Okay. Just in few seconds, I want to introduce to you Bangladesh. We all know the Bangladesh is a small country in between the eastern India and western India. So, and it's a disaster-prone country, and all type of disaster, what we call it's a super mall of disaster. It's a Bangladesh because of its geographical location. You know, you see, this is the location of Bangladesh, and this Ganges river basin, this Brahmaputra river, and this Himalayan tectonic plate boundary, all are actually made vulnerable to this small country. So actually the ferrocement might be the best option, best opportunity for countries like Bangladesh. Let me introduce with some terms and just to recap some terms and definition related to this presentation. This sustainability, what we understand, meeting needs without harming future generation is the sustainability. So actually we love ferrocement because of one of the main reason is its sustainable technology. And this embodied energy, pre-use cumulative energy to make a product. And the operating energy, energy used during a building's use phase. Then carbon footprint, total greenhouse gas emissions expressed as carbon dioxide equivalent. And life cycle cost, cradle to grave, total cost of ownership. And social cost. Social cost is the private cost plus external cost minus external benefit. Finally, alternative technology, greener alternative to mainstream technologies, because anything different from the conventional one is not the alternative technology. Alternative technology is the greener alternative. So embodied energy consumption, just with some example, this is example from Bhopal, India, is the Bhopal affordable housing design solutions. So the energy used for brick is the major, actually brick contributes the major energy and carbon footprint of a building if we use brick in the building. And then the cement is the 38%, brick is the 58%, and plaster and others is the small amount. And this is the actually embodied energy starting from the building 2 to 3 years. Initially what we use is the embodied energy, and for 40 to 60 years then the upper part is the operational energy, but ongoing embodied energy is there, and finally it's the demolition or recycling, whatever it is. And regarding the material selection and energy consumption, because I believe the architect can play a major role for making a building sustainable. It's not the engineer, it's the architect, because the building material selection is the job of an architect. The engineer is mainly select the structural system, structural frame, but most non-structural and finishing materials selection is from the architect. So architect can play, I think, vital role for making a building energy efficient and sustainable. So every architect, we should have this form of chart in our design room, that what material contributes, what material have carbon footprints, the value is what. So in brief, the aggregate is very low, then CC block, then concrete, then mortar. Is a mortar 1:2 mortar is for ferrocement. Usually without ferrocement for other work, we don't go for such a rich mortar. So if it is 1.2, the energy consumption is 1.3 if we use composite cement. But if we use ordinary Portland cement, then the energy consumption is more, 1.3 to 1.6, because we know that if it is composite cement, then maybe 30%, 35% you see fly ash or blast furnace slag is there, which is not contributing as much as a clinker contributes in the carbon. So considering these actually things, we have to select our building material and technology. Next, if we consider the energy consumption, operating energy consumption, this is a chart for USA. So in the USA, the energy operating energy consumption is the 45% of which is from space heating and water heating 18%. Then actually, especially in the rural area and low income people, they don't use this space heating, water heating, then space cooling, and lot of some other. Yes. So I have calculated almost 80% of this chart, which is applicable for USA, is not applicable for countries like Bangladesh. Maybe for India, I am not sure, but Indian, you people, you know better. So if it is not for Bangladesh, and in that perspective, lot of buildings are India and Bangladesh, and Bangladesh is the owner of the highest green garments factory. They claim that these are the green garments factories. So how these garments factories are green? Because they have LEED certified. They are LEED certified. Though from that point of view, I am actually I don't agree with this certification, because that LEED certification is good for USA, is not at all good for countries like Bangladesh, because this LEED does not give due weightage to the embodied energy. That give much more weightage on operational energy, and that is very much justified for actually USA or European country. Even the European country UK, they don't use this lead. They use bream, and because even in Bangladesh now, so actually Bangladesh, India, we have to develop our own green definition. But before that, in Bangladesh, what I am advocating for one is EDGE is from IFC of World Bank. That is very simple, and that gives equal weightage on this embodied energy, say operating energy, embodied energy, and water use. If one can reduce the 20% of operating energy, 20% embodied energy, and 20% water use energy, then that building will be eligible for getting this age certification. So in absence of our own, so I believe that might be the next option. And this is the one National Ready Mix Concrete Association USA, that 2015 to 30, the building material embodied energy is 74%, and building operation energy is only 26%, even in USA. So indoor comfort of the structure is so my organization HBRC's research work. So this is a bamboo bush. So in the bamboo bush there was a thermometer. In the ferrocement roof there another thermometer, and the CI sheet roof and wall another thermometer. So when in the bamboo, below the bamboo bush, the temperature is 35, then below inside the ferrocement roof it is 37, and inside the CGI sheet actually it's more than about 75% of houses, especially in the rural houses in Bangladesh, are CI sheet roof. That is why it's most important for us to actually have the alternative of that CI sheet roof. So, but in the CI sheet roof, under the CI sheet roof, it is 45, 10 degree more. So it's very much unhygienic. Some of ferrocement work in Bangladesh, it's a 5-story building. It's a 2-story. The left one is cast in situ, and the right one is the precast ferrocement building, and it's a cast in situ. These are the this build is a school building, and this is for the coastal area where there are tidal surge, stilt house. So depending on the data what we have from our water resource department, how much probable tidal surge might be in a particular area. So based on that, we determine the ground story height. And during normal time, people use both ground story and first floor. When there are alarm, early warning for cyclone and tidal surge, then they just leave the ground floor, they go to the upper floor. So this actually is the HBRC's, my organization actually suggested these houses, but this concept is not yet widely applied, but people day by day, people are accepting this concept. Because usually in the cyclone prone area, people are used to not to go to, they are not willing to go to the cyclone shelter, because leaving all the valuables, people are not ready to go to cyclone shelter, and there are other social problems also. So if what I believe, that if we can introduce this concept, then they don't need to go to the cyclone shelter. They can go stay in their home. And the right one is the school building. So it's only all floors are precast ferrocement panel, and it's a school primary school building, and this one is a floating primary school. So it's a flood prone area. And these are the things actually using this ferrocement. We HBRC, we work mainly with the rural community because in Bangladesh, lot of engineers and architects are there to support the rich man's house, but no architect, no engineer in Bangladesh. Though we engineer and architect in Bangladesh, we studied in the public university with the poor man's money, but after passing out, so we work for the rich people, not for the poor people. I don't know what about in India. So from that point of view, my organization, we are dedicated to work with ferrocement for the rural community and low-income community. These are the precast, and people like CGI sheet in the rural area very much. So we have actually recommended this ferrocement, corrugated ferrocement sheet for the rural people. And this 5-story house, if we analyze this 5-story house, is the footing, beam and column is the RCC. And all others, other things is the floor, staircase and others is from ferrocement. And after analyzing, what we found is the 32% less carbon emission in compare with the conventional one, and cost saving is 30%. So why don't we go for ferrocement? And this is a rural house. This is a government house for the homeless people, and this is the alternative from our organization. So with the same area, and we go for a comparative statement between the semi-permanent. We call it semi-permanent because the floor wall is permanent. Wall is made of brick wall, but the roof is CGI sheet. So we call it semi-permanent. It's not permanent, but ferrocement one is the permanent. So if we compare, we call this the private cost is for the ferrocement. The private cost is 85% of the conventional one, and energy consumption is 43% only for the conventional one. Carbon footprint is 35%. Social cost is 80%. Life cycle cost is only 35%. Portability, because in Bangladesh, we say riverine country, so lot of people, every year almost 100,000 people actually they lost their houses. So portable house is most important for those people. So a portable ferrocement house, actually what we are trying to introduce in our disaster management concept. So portability, from portability point of view, the semi-permanent is not portable, but ferrocement one, you can make it portable. This is not actually portable because the wall is not ferrocement. We have another presentation from our side. So 100% portable and fully 100% ferrocement material. Indoor comfort not good, good. Topsoil loss is a problem. It's a severe problem for Bangladesh because even in India, it's more or less 40 decimal agricultural land per capita, whereas in Bangladesh it's only 10 decimal. So it's very much actually alarming for Bangladesh for our food security. From that point of view, actually we cannot afford this clay burn bricks. So topsoil loss is there, and for ferrocement is not. The maintenance hazard is yes for brick, but for ferrocement is no. And one thing is actually this Pune, I was thinking what is the difference between Pune and Bangladesh. I find one major difference is because while I was translating the ferrocement book of Professor Debekar, then in the starting, he says the sand, crisis of sand. But in Bangladesh perspective, we have lot of sands. We have the crisis of stone. 100% stone we have to import. But we can even export the sand. We have lot of sand. So that is the difference, I think, between Maharashtra and Bangladesh. Here you have lot of stone, but I think less sand. So we have to actually find out the solution based on your community based. So this is just an example that in 1984, a building of ferrocement, precast ferrocement panel in the roof, but in odd size span, they don't go for shutter formwork. They just fill that by using conventional concrete. After 45 years, now the concrete portion is like that, but ferrocement part is completely okay. So the durability of ferrocement is much more than the regular concrete. In Bangladesh, we use the brick chips for coarse aggregate because of scarcity of stone. So that is even worse for the concrete to use. And recently we have designed for retrofitting, and conventional retrofitting is the concrete jacketing all around the column. And now we are proposing the ferrocement jacketing. But what we found, if we go for ferrocement jacketing, either oval shape and circular shape, then it gives a better result and a detail of the ferrocement. Thank you very much.
Thank you, sir.
No question.
Any questions? Anyone has? So.
Actually, until today, we have constructed two-story, 100% column, even footing with ferrocements. But beyond that, we did not try yet. But I think we should not go for high-rise with ferrocement because it's from structural point of view, from safety point of view, we need more research on it. Otherwise, we should not go on it. We are on the research phase. I, I can't hear you, please.
Hello.
For a two-story building, like you had mentioned that the
Hello.
column and the beams were designed with the ferrocement only. So what kind of codes or the basic principle you would have used? Because as per my understanding, ACI 549 is the one which talks little about the design. Other than that, no codal or the regulatory framework so far, as per my understanding, is not there.
Okay, you are very right. Actually, for Bangladesh, we have our own building code, but we say it's our own, but it's not our own. But we copied from ACI. So, but that is for actually high-rise building, multi-story building. But we don't have our you see housing code, especially as for example, Bangladesh is earthquake prone. So in our code, the minimum column size is 12 inch by 12 inch. So now if you go for a one-story building frame structure, two-story building frame structure, so it is not wise to go for 12 inch by 12 inch column. So what should be the minimum column size and what should be the reinforcing bar, that should be in the housing code, especially in the rural housing code. That is not present at this moment. So actually I am working on that for developing a rural housing code. So before that, what I am doing, I am just for one story, two story, with some more factor of safety. Actually, I am using this for two-story building. Not more than that. I am using that ferrocement. It's circular. You see circular section, rectangular section, and T section. Sorry, I section.
Can I speak something, ma'am?
Yes, yes, sir.
In India, the story is different. In India, we have moved far ahead, and we are no longer interested or looking at the American code 549. The 549 is a completely outdated concept of ferrocement, because it talks about ferrocement, and at the end of the code it says that please neglect the tensile strength of ferrocement, which is a big misnomer and a disappointment. In India, we have now completely worked out on the modalities of design, the stress strain curves, the testing, the factor of safety is the calculations that we can make for ferrocement structures. And now we have already gone ahead and made the first of its kind code, and 5 chapters have been submitted to the Bureau of Indian Standards. The next 3 chapters will be submitted soon, and the first ever code in the world which takes care of the actual calculation of actual tensile stresses will be there for not only for India, but for Bangladesh, for Sri Lanka, for all our neighboring countries. And I thank Dr. Devekar for leading the thing and training me to come to that level where I could make a draft copy of the code and submit it to the Bureau of Indian Standards. So we are far ahead of everybody, and the questions that are raised by him are completely now eliminated at this stage. We are moving much more ahead.
Yeah, you are very right. Actually, after becoming in contact with this Indian Ferrocement Society now, I don't follow the ferrocement design of ACI code. I follow Professor Dibakar's theory. Yeah, so following that, actually, I am actually in the initial stage of designing the column, beam, these structures. I have started, but I have not enough confidence to go beyond 2-story. Yeah, yet maybe we'll will go within a short period. Thank you.
May I just a few minutes? Just in continuation with the same question, I want to add few things about the development in the documentation of the IS codes which are available for the designing of the ferrocement structures. So, being a founder member of this society, and of course with the help of Dr. Bnca Pune, who is the pioneer in giving the design concepts for the ferrocement in different ways. So, your question was about the multi-story design of the buildings, right? So regarding that, as Abu Sadiq ji has rightly pointed out, that up to 1 or 2 stories we can easily go with a conventional design of the ferrocement, 100% ferrocement buildings. For the higher rise buildings, we can certainly go for some components, as he has built 5-story building with RCC as beam column frame structure and other components in ferrocement. But for the high-rise building also, and particularly for any intricate type of design in buildings, the Ferrocement has developed, this society has developed a new concept of design itself. It can be like a cubicle box type structure, because all wall panels, slabs, all are in Ferrocement and in one go. Those are casted in situ, or we can use the precast elements also. And in that concept, then we can build multi-story buildings also. Of course, here more than 2 to 3 stories we have not tried yet here. But documentation and particularly the design theory is now ready. It has been published. A book is published by Dr. Divekar, and it is available with our Ferrocement Society. The details are on our website. The design manual is there, construction manual is there, and Government of Maharashtra has also published a complete Ferrocement manual, including designing and construction, and that is freely available on website. So this is just for information for you all.
Okay, thank you, sir. Actually, I have all the public books from Professor Divekar, and I follow those books, yeah, not the ACI code. Thank you.
Hello, sir, Sadiq sir. Thank you so much, first of all, for giving this presentation. And I want to congratulate you first that you have shown all your expertise within last 20, 30, 40 years that you have worked for. I am being from architecture fraternity. I have a curious question about, since ferrocrete is looked up to use of it for temporary structures, means not so very permanent structures, nor it has, we can just go for a high-rise structure with it. So it is just, at present it is being maybe experimented with just 1 or G+2 or G+3 maybe, not beyond that. My basic question is, how do you deal with the foundation of it? Because that comes as a very basic question for architects in order to go for some design for a building. We can go for temporary structures, for pendles, for any other things. You have given us 2-3 slides here which shows about related to earthquake safety and the floods, that the structures were raised enough so that water could be quickly settled off or quickly drained out. So have you also treated some special kind of foundation there which could be applied in ferrocement, or please give your views on it. Thank you, sir.
Okay, thank you. Thank you. Very good question. Actually, as you say, the ferrocement is not for temporary structure. It's the durability is much more than even RCC concrete for ferrocement. So this is one issue. Second is to use in the foundation, ferrocement to use in the foundation. You see, we have 5-story buildings, masonry buildings, unreinforced masonry buildings. We are, Bangladesh is very much earthquake prone. Even then, we have hundreds of thousands of buildings on just masonry foundation. No reinforcement is there. So for 1-story, 2-story, even we recommend the masonry foundations, but in the severe earthquake zone, we don't recommend even 1-story, 2-story unreinforced masonry. So, but if it is ferrocement, it's far better resisting capacity than unreinforced masonry. And for 1-2-story building, the the footing, the foundation size is small, so we precast it. We actually cast in other side, and we put it in the. I have the video, maybe later on if I have time. Just how actually we made this foundation for two-story building, and how we join the column with the epoxy glue. All these details are there with me. So maybe if we have time in another time, we will go into detail. Thank you very much.
Sir, I want to add something with Power sir. We have already given recommendations for BIS code, and we can make it available tomorrow. That booklet is here, but I can show to the interested people here tomorrow. I can bring it here, and so many questions are there, but we can answer it later on. And thank you.
Okay.
Interested people can see it tomorrow. We'll make it available. Copy of it.
That was quite interactive session. Sir, may I call upon stage Dr. K. Sundaram? He wants to have a few words.
First of all, I'd like to thank Sadiq ji for his very wonderful presentation. Message to all youngsters here is, I would like you to understand a very important part which he mentioned. When we become engineers or architects, we should not just end up working for the rich people. And as he said, he's worked for the poor people housing in Bangladesh. Please give him a big hand for this. तो लंच के टाइम तो रोटी हो गया, रोटी कपड़ा मकान बोलते हैं. सो रोटी के बाद अभी मकान का हो गया, हाउसिंग. ही वाज फ्रॉम द हाउसिंग इंस्टीट्यूट. कपड़े का होगा यार, कपड़ा. तो नाउ आई हैव गॉट somebody to speak about कपड़ा. So when you say कपड़ा, it will be Geo Textiles, and I think the next speaker will speak. है ना, बराबर है ना, रोटी कपड़ा मकान, लेकिन थोड़ा सीक्वेंस उल्टा सिल्टा हो गया. Clear? So at first it was रोटी, then it is मकान, अभी आएगा कपड़ा. All right. So the next speaker, she'll introduce the next speaker. Thank you.
So we have our next keynote speaker here, Dr. V. Govindraj sir. I request sir to please come on stage. I request Dr. Sundaram sir to felicitate Dr. V. Govindraj. He is our next keynote speaker. Thank you, sir. Sir, you may please wait here. Sir, it is here. Dr. V. Govindraj landed Pune some time back, and he joined the session immediately. It might be a little stressful to you, sir. A warm welcome to you. Dr. Govindraj sir is from R&D head of L&T Constructions, Chennai, with 30 plus years of experience in teaching, design and research. He developed the softwares for structural sizing of tall buildings. He has authored 25 plus publications, Then he has authored reviews for ASCE journals and collaborated with institutes like IIT Madras, CBRI Roorkee. Request you, sir, to come upon the dais and enlighten us with your thoughts. Thank you.
Pointer is there.
I'll just arrange for that, sir.
just copy it on desktop because
You can copy the entire folder.
okay. That's it. I don't know what's happening.
Your caller mic.
I like it.
Pointer.
Yeah, pointers. She's arranging.
You can just right click, copy text.
नाही हे काढलेलं आहे पेनड्राईव्ह काढून टाका पेनड्राईव्ह काढून ते टीम्सची मीटिंग आहे ऑनलाईनची
कॉपी नव्हतं का केलं यांचं
नाही आत्ता आले ना सर चेन्नई जस्ट लँड
ते पहिलं प्रेझेंटेशन बंद केलं नव्हतं
प्रिंटर आहे पण ऑप्शन सांगायचं
काय नाही ऑन करायचं
त्या साईडला
आणि त्यांनी प्रेस करायचं कुठं ते बंद झालं लॅपटॉप हँग झाला
This one for slide movement. This is for slide movement, right? First let it come up. Very good afternoon to all of you. Sorry for the initial disturbance, technical, this thing. First and foremost, I would like to thank the organizers for having given me the opportunity to be here today among the younger fraternity. In fact, I am really pleased to be here in this institution particularly because I came to understand that this institution has been established long back with the noble objective of uplifting the socially underprivileged society. So I'm really very proud and excited to be here. And today, the theme of the conference is Art, Science and Technology of Ferrocement. You might be wondering as to why this topic is there suddenly textile reinforced concrete. In fact, textile reinforced concrete is the granddaughter of ferrocement. So ferrocement is the cement matrix and the metal reinforcement in the form of a fiber or the weld mesh is embedded. Here in place of ferrous reinforcement or metallic reinforcement, non-metallic reinforcement is there, and that is having the equal characteristics. So that those things we will see. At our R&D center, we are working on many pioneering works like TRC, 3D printing, and geopolymer concrete without cement, because L&T has taken a commitment to achieve the carbon neutrality by 2040 and water neutrality by 2030. So as you know, concrete is the most widely used material next to water. So concrete is predominantly, cement is the main material, other materials are just inert material. So 1 kg of cement produces approximately 1 kg of carbon dioxide. So what is the way how we can reduce the carbon dioxide emission? That is the key, right? And similarly, if you reduce the use of the steel, then we can considerably reduce the energy for production, which indirectly reduces the amount of CO2. And these PPTs have been prepared keeping in view that most of the audience are architectural students. So my presentation will be on the engineering front. So of course, I will try to convey the essence of the presentation, right? And GDP of around 4.18 trillion, and very soon we will be moving to the third position. All these developments, GDP developments, will always be accompanied by the infrastructure developments. So architects and engineers are playing a major role in establishing the infrastructures. So they have to go work hand in hand. So architects, they work on spatial planning and natural aspects, and they like curved structures, whereas engineers like straight structures, straight line structures. So there should be a judicious combination of both curves and straight lines for the successful infrastructure projects. So since the concrete is the most very widely used material, so architects should also know more about the materials. Of course, it's a big subject itself. Today we will just focus on the concrete, and gradually we will fall into the ferrocement and the textile reinforcement. So as you know, the concrete is the material which is composed of different aggregates, fine aggregates. Today we are using many admixtures, mineral admixtures and chemical admixtures to have a larger open time, and in which the vital role is played by the cement, right? And this concrete is a very simple material to fabricate, but it is subject to a lot of variations in its properties, and greater quality control is required with respect to water, mixing, consolidating. And you can just see here, these are all the parameters which affects the properties of the concrete, right? So all these things has to be kept in mind, and we have to do the proper mix designs for the successful life of the structure. In fact, the life of a building is dictated by not by the life of the concrete, life of the steel, because steel is the one element which undergoes corrosion, which defines the life of the concrete. So if we look into the different types of concrete today, we have self-compacting concrete, which is most widely used in most of the infrastructure developers. L&T is by and large using this SEC. The concrete is being pumped to even 50th floor, 60th floor. That means you have to have a proper rheology, the viscosity of the concrete. So without any compactions, we can just do these self-compacting concrete. I'm just giving the different types of concrete for the purpose of keeping in view of the architectural students, because they should know which type of material is to be used for which applications, right? And the structural lightweight aggregate is also there. There again you have non-structural lightweight and structural lightweight. Non-structural lightweight It is basically by changing the type of aggregates. So we have a LACA aggregate, light expanded clay aggregate, which is basically a concrete is having a density of around 600 kg to 900 kg per meter cube. It can be used for non-structural purpose. Whereas we have sintered fly ash aggregates, which is being manufactured in Odisha, a place called Katak. There, using those artificial aggregates, we can make structural lightweight concrete also, and it's also being used extensively, and that we can make a concrete up to a grade of around M40 grade concrete. There is a specific codes are there, and we have ultra high performance concrete. Today, for mostly we will be using M20, M30 kind of things. We are now working on M150 grade concrete. So we have achieved it. Even now we are planning for 180, that is 180 Newton per millimeter square, which will be predominantly used for the long span infrastructure elements, precast elements, and it will be used for the pre-stressing. And the heavy density concrete, I am just giving the different types of concrete so that you can understand for the architectural students. So concrete generally it will be having around 2,400 kg per meter cube as a density. By changing the aggregate type, like a hematite aggregate or barite aggregate, we can make a concrete with a high density, which will be typically having a density of around 3,400 kg per meter square. And this type of concrete are used in the nuclear containment structures, those kind of things, where radiation is a criteria. And we have pervious concrete. Particularly for the architectural students, we will be interested in the rainwater harvesting, where we will be using the paver blocks in the outside environment. Instead of paver blocks, you can have a concrete itself with no fines, but you can have a gap graded aggregates, which allows the water to percolate, and it gives the rigid surface also. You can use it as a parking kind of things, right? So this is also coming up, and we are using in many projects. And colored concrete, architects prefers the colors. So basically 4 or 5 different colors can be used by adding a pigments in the concrete itself, so which will be lasting for the year. In fact, L&T has done one white concrete building for in Delhi for Shivanadar group, HCL group, where white cement is used, white aggregate is used, that is dolomite, and white titanium dioxide is used, that is the pigment used to bring the white colors. So likewise, it is possible to have a different types of colored concrete itself. Of course, it involves cost also. So based on the this thing, we can do it. It's not a painted one, right? So once we know the concrete, what type of concrete to be used and what type of cement to be used, because it's a big science, people have to use the use of a type of cements. So we have different types of cements: OPC, PPC, PSC cement, PCC cement. So which cement is used for which building? For example, if your ground is containing sulfates, more sulfates, then you have to use the sulfate resisting cement, or you can even use the cement with GGBS, that is ground granulated blast furnace slags, right? If you are focusing on this carbon emission, you can use more fly ash. So this, you have to use the different kinds of admixtures, mineral admixtures. And next, coming to the rebars, we know mild steel is there, which is having a higher ductility, but strength is less. We have a cold twisted bars, mild steel bars, but it is in a ribbed form that gives more strength. And third one is today most extensively used in the market is TMT bar, thermomechanically treated bar. The bar is heated and suddenly cold, made to undergo lower temperatures, that is called quenching, by which the rebar will be having a outer layer which is very strong. That suppose if you are having a 25 mm diameter bar, there will be an outer layer which is not visible to your eye. It will be about 0.1 times the diameter of the bar. That gives the strength. The inner core is giving the ductility. So that both strength and ductility can be achieved by using a TMT bar, which is predominantly used today. And we have epoxy coated bars, which is mainly used for the coastal structures, because the major problem for the steel is the corrosion. Even in ferrocement also, the rebar is likely to undergo corrosion. So we can use the epoxy coated or galvanizing of the steel, so that the life of the concrete can be improved. Today, people started using the GFRP bars, that is glass fiber reinforced bars, which is available in the market, which is having a very high strength but no ductility. So it cannot be used in all places. It has to be used very carefully, where strength is the criteria, deformation is not the criteria, because Young's modulus of GFRP bar is almost 1/4 of the steel bars. And the corrosion resistant bar, today people started using this corrosion resistant bars in addition to TMT, where they use the special alloys like titanium dioxide, vanadium, those kind of elements are used to bring the corrosive resistance. So the point what I would like to insist to the students is that they should know complete what are all the different varieties of cement, varieties of concrete, varieties of aggregates, varieties of steel, which combination used to be used. It's not simply concrete. And this is only selection of the material. Next design, next how it is placed, everything has to go. It's not the responsibility of someone else, right? So everyone has to have a complete grip of the subject so that the structure will have its intended life and the functionality. So we know with this, whatever the material we have seen, we can make the reinforced concrete of any grades. In addition to the steel, today people started using the fibers also. So different types of fibers, which is, you can see steel fibers are used mainly to bring the more toughness, because the concrete is very brittle. If you want to increase the energy dissipating capacity, you have to add more steel fibers, which bridges the internal micro cracks. So thereby it is able to dissipate more energy. So that is bringing the plasticity to the concrete is by adding a fiber. And the polypropylene fiber, this is used in a concrete where the fire resistance is to be increased, mainly for the high-rise buildings, for grade of concrete above M80, M90 and all. Higher the grade, lesser will be the fire resistance. So if you want to increase the fire resistance, you have to use these polypropylene fibers around 0.1 kg per meter cube, so that during the fire time, these fibers will melt at 160 degree, and it gives the ways for releasing the pore water pressure developed inside the concrete, right? So carbon fibers are also used. Glass fibers, it is basically made from the silica sand, which is heated to around 2200 to 2300 degrees centigrade, and it is in a molten form. It is made as a fiber using the fiberization technique, right? So organic fibers, nylon fibers, polyester fibers, all are there. Even sometimes fibers are used to reduce the shrinkage of the concrete. So those you might have seen, for a larger horizontal slab concrete, during the peak summer time, once you lay the concrete, within 4 to 5 hours you can see popping up of cracks on the top of it. It is due to the shrinkage, that is called plastic shrinkage. To avoid that, you can use these kind of fibers so that it takes care of the stresses developed in that. So each one has its own purpose. This has to be kept in mind, right? So next one is, as I said, this glass fiber reinforced polymer, GFRP bar, which is now it is widely available. Dextra is a company which is giving these fibers. This can also be used. It is completely corrosion free. Whereas the conventional steel is a corrosive, it has to be treated separately, whereas this is corrosion resistant, but it has a lesser Young's modulus. That is the problem you can see in the modulus of elasticity is only 40 to 50. The meaning is, suppose if you have a beam, you have a conventional steel, if it deflects by some 5 mm, if you replace the steel by this GFRP bar, the deflection will be less, but deflection will be more, whereas the fire resistance is very less. So it cannot be used unless you take care of the fire resistance. This cannot be used, right? So these are all the different types of bars available. You can just see the load deformation graph. The steel bar is having a larger plateau, right? Usually this portion is called, it is having larger stiffness. If the larger plateau, horizontal deformation is there, that means that bar is able to undergo longer elongation, able to dissipate the energy in the plastic zone. Whereas for GFRP bar, only straight line is there, that has more strength, but there is no ductility. So under the event of earthquake, these bars, these kind of structures will not dissipate the energy. So we have to judiciously use where to use the steel bar, where to use the GFRP bar, where corrosion is important, where fire resistance is important. So keep all those things. It's not just a rebar, purchasing it and placing it in the member. Now coming into the ferrocement, in fact, it is about 5 decades or even more technology. It has been used for thinner elements, mainly for the thinner elements. If you look for the shell structures or folded plate, for a larger spans, if you want to have a roofing, thickness can be reduced. It can be in a curved form, so that under the load, the stresses generated will be in the in plane. The out of plane bending will not be there. So wherever there is a member, which is subject to in-plane bending due to the external forces, then the ferrocement or textile reinforced kind of structures will be useful. So where it can be used, it goes to the extent to your imagination. Even for metro piers, we are now just exploring in L&T. We have huge scaffolding and formwork for the piers. Typically, if you see the metro piers, it is having a size of 2 meter by 2 meter, right? It occupies a larger space. Instead of, we can have a ferrocement formwork panel which is about 30 mm or 40 mm thickness. It can be placed and you can keep the reinforcement, pour the concrete. It becomes a sacrificial formwork, right? So those kind of things can also be thought of it. So similarly, it can be used for these kind of roofing structures. If you see the applications, mostly it is for the curved structures, because where the stresses will be distributed in the form of a skin stresses, that is in-plane stresses, right? It cannot be used, or it has a very limited applications for the flexural members, which is undergoing a bending out of plane. For in-plane bending, it is best, right? And next is textile reinforced concrete is also the evolutionary form of a ferrocement. Whereas in a ferrocement, we use this metallic reinforcement. Here, this is a non-metallic reinforcement, which is free from, non-metallic means it is free from corrosions, right? But all these fibers, you can see it is made by, now we are working extensively on this product. We have implemented in some of our projects also. So this is, we are getting the fibers from the Saint-Gobain, right? So it is again similar to ferrocement. Only thing here, in place of this steel mesh, it is a TRC mesh, right? A textile reinforced mesh. And these are all the different names given. The fibers are running parallel to the weaving direction. It is warp, and this is called weft, and this is called roving. Likewise, it is manufactured. It is basically manufactured from the woven technology, right? So there is a code, IS code is also coming up, CED 54. I am also a part of this member, which is headed by the Structural Engineering Research Center in Chennai. So some of the applications of textile reinforced concrete is very lightweight, and it is non-corrosive, very high tensile strength, high elongation. So though it is not having a ductility, because it's a glassed reinforcement, but it has a very high strength. So it exhibits lot of elastic behavior within the elastic limit and high Young's modulus. So you can just see what is the comparison between ferrocement and TRC, where steel mesh is used. Here it is a textile reinforcement, that is, it may be a glass or carbon or basalt rock, and corrosion is possible. Here it is corrosion free, and thickness, all these things are given. And different types of fibers available. It is alkali resistant glass fibers, which is a little costly. Now what is extensively used is a E-glass, electric resistant grade glass. Those glass, it is 1/4 of the cost of the air resistant glass, and it is available from the vendors. Carbon fibers. This carbon fiber reinforcement is mostly used for the retrofitting purpose. If you want to increase the strength of the existing columns or existing slabs, then these carbon fibers, because carbon is having a very high strength, and AR means alkali resistance. So one thing that what we need to understand is, in case of a steel bar, the destruction of a steel is due to the corrosion, either due to the carbonation induced corrosion or chloride induced corrosion. Whereas in case of these glass fibers, the failure mode is by a method called as alkali silica reactions. This glass fibers are having a lot of reactive silica, because it is manufactured from the silica sand, which is heated to 1200 degree and suddenly reduced. So this contains a reactive silica. When it is in contact with the alkaline material, there will be a formation of the alkali silica gel at the surface of the fibers, which leads to the failure or deterioration of this concrete. So what we have to do, those fibers should be coated with alkali resistant coating, that is epoxy coating or SBR coating. Those can be used, or you can use the alkali resistant glass itself. So those things can be used, basalt fibers. So there are different forms of fibers are there, but most widely used is the glass fiber, because cost is very less. So you can, some of the tests what we have done at our laboratory, you can see the load deformation graphs. So it has a very high strength, that is, this is the initial elastic portions. Then there is a reduction in the loads gradually stepwise reduction, because it is not all the fibers will lose its strength simultaneously. One fiber will lose its strength, then subsequently another load will be redistributed to the another fiber. So there will be a gradual reduction in strength by which we can get the ductility. You can see the next diagram, and we can measure the elongations of these fibers by using a video extensometers. So using video extensometers we can find out these elongations. So these are all the some of the tests which are used to find the durability parameters of the fibers, that is residual tensile strength. These fibers and all, it is immersed in a highly alkaline material, right, which is typically having a pH of around 13.5, and it will be immersed for about a week time, and then it will be tested. So we will find the strength before and after, how it is reduced. So this is one of the tests. Of course it will be incorporated in the upcoming code, and we also do, this is the typical test that will be done for the measuring the elongation of the members, for that is called EISR test, right. So cementitious matrix, what is the matrix used for this textile reinforced concrete? Is similar to your fiber reinforced ferrocement. Here also we use the cement and fine aggregate. Only thing, the size of the fine aggregate is limited to maximum 2 mm, because it has to penetrate through the small grids of the textile reinforcement. You can just see how it looks there is a problem. Okay, so you can just see how the mortar is flowing. So it is in a very flowable form, and it has to be measured by using this. This is called a slum cone flow. So there is a separate method by which you have to design the cement matrix, and it has to be poured, and these are all some of the equipments used to measure the durability characteristics. This is called water permeability test. This is called a chloride permeability test. So all these things has to be designed before arriving at the final matrix. And this is some of the elements which we have done. In fact, we have a tie-up with the Structural Engineering Research Center, Chennai, and we want to explore this use of this TRC for the around 5 different elements, like pipes which are used for carrying the water. So we want to use the TRC technology for the pipes, and also for the partition walls, and also for the valve chambers. Likewise, we have different elements, and this is just one simple slab which is used for using this TRC, right. So you can just see the finishing of this TRC elements. The TRC elements, typically it can be made as thin as 15 mm, and it can go up to around 40 mm, similar to exactly ferrocement, right. Now you can see here, this is the ferrocement, which is having a thickness of around 25 mm. You can just see a person who is standing in our laboratory, just to get the feeling of how it is able to take the load. And we have measured the deformations also under the load. You can see here, though the fiber is a brittle fiber, you can see there is a large plateau. This is called large ductility. So these fibers, even though it is brittle, it is able to give the large inelastic deformation under the load, right. So this is the peculiar nature of this TRC panels. And if you see the first diagram, if you test the fiber alone, it will be having a straight line, that is strength. There will not be any ductility. If you use only cement matrix, that is concrete, there will be a sudden decrease in this is called strain softening. When you use both TRC fibers and matrix, cement matrix, you will get a diagram like this. That means you will be having a strength and also strain hardening. This is called strain hardening. So strain softening is converted into strain hardening. So this is one good unique nature of this TRC that can be achieved. And since each fiber is composed of lot of filaments, even if the breakage of one filament will not lead to the sudden collapse. So it will distribute the loads gradually. That's why it is able to take the more load, right. So these are all some of the test setups which we have done to find out the permeability of the concrete. And we have one requirement peculiarly for lift irrigation project. L&T is doing on lift irrigation project in Odisha, where for distributing the water to the lift irrigation fields, we will be having a lot of bigger valves, controlling valves, which controls the flow of water. So that occupies a space of around 2.5 by 1.5 by 2 meter height. So for that, initially we thought of having a concrete room or steel rooms and all. So finally, since these rooms are to be, there are 3,000 numbers of such rooms are to be used, transported, and to be installed in different villages in Madhya Odisha. What we thought, we can have a precast members. This corner, you can see, this is a precast columns of small elements, and these panels and all, it is a lightweight TRC panels. So we have made it, and it is like, you can just see, it is it is free from reinforcement, these panels. Of course, these columns, it is like a minor steel reinforcement is there, and we have successfully done it. We have got the approval from the CPWD department, and it is installed. Around 3,000 numbers have been installed. The advantage is it's a light in weight, it can be easily transported, and less labor is used. And we are now exploring the use of these panels for further applications. So you can see some of the site works being done, and some of the load tests what we have done at our laboratory. You can just see a TRC element undergoing large deformations. If you remove the load, it comes back. So that is the elastic recovery, whereas it will be not possible for the steel reinforcement, because it is dissipating the energy and the inelastic deformation will be more. Here it comes back to its source. That is one of the advantage, and you can see the reduced construction time. The steel is not very less, 42% less in compared to concrete chamber, right? So CO2 reduction is to the extent of 637 tons, right? So it's a very sustainable product. And now we are thinking how to use this TRC for the pier, for constructing the large piers for the metros. You can just insert the like a plywood formwork. You can make a 40 mm thick square or rectangular formwork, place it, keep the reinforcement, keep the concrete, and it becomes a final formwork. That is called a sacrificial formwork. And we are also trying to use it as a pipe structures, and for the security cabins, and for the partitions, so on sajja, balcony. So it can be used in many places. Only thing you have to judiciously design the correct mix, select the correct fiber, all right, and it, with the proper design it can be used. So these are all some of the areas where we can use. So in some of the globally it has been used for, this is Technical University of Dresden, Germany. I have been to this university, and they have done this mock-up structures using this TRC. This is precast garage, and several applications has been done. And mainly it is for the thin elements. If you want to have your roofing structures, it can be made with this kind of things. You can see what is the comparison when it is a TRC or FRP, fiber reinforced polymers, or conventional GI, or what is the different parameters, flexural strength, fire resistance, all those things. All right, you can see it. These are all some of the applications, because architects may be interested in having these kind of things. And of course, this is now possible with your 3D printing also. And by using TRC panels also you can do it, or even you can use TRC as a fiber with the 3D printing motor. So that can also be used, right? So even we can use it for the geodesic, where the load is transferred through this triangulated framework. These infillings can be used by using this Ferrocement, or even the TRC also can be used here. So just I am giving the different applications where we can use this technology. This is being used in foreign countries, urban footprints, and particularly it is for the facades it can be used. In fact, there is one Pune-based industry, Reina Industries. They are developers of this TRC technology. I had interaction with him also. In fact, they are making all these kind of facades even for L&T also, and you can just see how it has come out. So portable structures, Kalyanasam sir, you are telling now. So this can also be used in portable structures, and for airport hangars, which is typically having a larger spans, there also we can use it. In fact, for the industrial buildings, normally what we do, we will be having a steel trusses over which we will have a galvanum sheet. Instead of, you can have a TRC panel itself as a cell structures, so thereby you can avoid this trusses and all, right? That can also be, we can use it, of course, with the proper design calculations. You can just see some of the architecture elements. In fact, not only for the architecture purpose, unfortunately, I am not able to show the video. This can be used for the retrofitting of the structures also. As I said, the carbon fibers can also be used. Actually, for one of the, this video is actually showing the retrofitting technique for used adapted for the bridge decks. So there is a pre-stressed concrete beams over which bridge deck is there. The thickness is around 150 mm. But the strength of the slab has to be, bridge deck slab is to be increased. What they have done, they have fixed these carbon fibers at the bottom and sprayed the mortar, and they have proved that the moment carrying capacity is increased. So that is the video, but due to some technical issue, I'm not able to show it. So even it can be used in 3D printable concrete also. Today, a lot of works are going on in 3D printing. As you are aware, in fact, I am very happy to see in some of the works are there used in this college. They have printed many structures using the clay, but L&T has done a 3D printed building itself. In Bangalore, we have constructed one post office building. Probably you might have seen in newspapers. So 3D printed building. In Kanjipuram, in Tamil Nadu, we have constructed G+1 story building. In fact, we have collaborated with IITM as early as 2016 itself to construct the first Swachh Bharat toilet using 3D printed. It is there in our thing. Now we have constructed one DRDO building in Madhya Pradesh. We are now thinking of using this 3D printed building for a 7-story building. But only thing is, printing is okay, but how to place the reinforcement in the wall? That is one key challenge. How to design the concrete mix? Because in a 3D printing, main challenge is to design a flowable mix. The mix has to come out, that is called extrudability. It should remain in its same, that is called buildability, right? It should be flowable. So all are having a contrasting property. So it has to be properly designed. That is called the rheological characteristics of the 3D printable concrete. So we have done those works and we have published many papers on that. So once you use this 3D printable concrete, you can use these fibers also in a way how it is, because it is highly flexible and the strength is very high, and you can manually place it, the strength will be more. So for architectural students, even I suggest you to make one mock-up structures in your campus itself by using a combination of the 3D printing plus TRC fibers. So these are all some of the structures that could be done with the 3D printable structures. The main advantage is 3D printing is you don't want to have a formwork, and the material wastage is very less, and you can do it in a way how you want. So that way you can do it. This is the bench, garden bench kind of things. I think I have given different kinds of flavor. It's basically what is textile reinforced concrete. Of course, it is a form of ferrocement. It's a non-metallic reinforcement. And if you understand the material characteristics, what is the characteristics of the cement, concrete, fibers, which fibers has to be used. If you do it properly, then it can be used for any structures, right? With this, let me conclude my presentation. Thank you very much for your presence here.
Sir, please wait for a few questions.
Yeah, please.
We will have a couple of questions. Sir, Mike.
You have used that TRC as a last formwork or sacrificial formwork. Have you calculated tensile strength of the same for columns?
Yeah. For columns, the strength is not, it cannot be used as a standard.
Because it is confined concrete, then you can utilize that tensile strength of the same for resisting compressive load.
Yeah, what we have done, we have done a formwork and poured the concrete.
Right.
And we have measured the extension, lateral pressures, formwork pressures all, but we found that it is less.
Okay.
Right. What we have done, we have given the external stiffening by using a temporary stiffening. Once concrete gained its strength, we can remove it.
That is usable formwork.
Usable form. The formwork is sacrificial.
Okay.
To resist the lateral force.
Okay. During concrete.
Stiffening.
During concrete.
Then
okay.
we have removed it. Once
because what happens by our experimentation and experience, if concrete is confined with some tensile type of reinforcement, strength of concrete resultant is much more.
Correct. When it is confined, it will take larger strain.
Yeah, that confinement is important.
Correct.
So that's why you are using that sacrificial formula. So if it is monolithic, then you might be able to use that one.
Exactly.
My question is, now you have done some R&D, have taken many tests in lab. Since there is no reinforcement as such, right, as like Ferrocement or even like RCC. So how you are going to achieve the flexural strength? Because I have seen the structures you have built using this. Those are basically achieving the strength through forms. So that idea you have used to increase the flexural strength. But my basic question is, have you tested the permeability of it? Because the water tightness is required for particular water retaining structures, or can it be used for the canal lining or maybe like the farm pond linings? So for that, how much useful
Yeah.
it is and how it can
It
be
is
used?
very good. In fact, it is very good candidate for canal lining. We have done the test called as a water permeability test. So I think I have shown one video also. So that water permeability is only just 9 mm. So you can see, you can see here, permeability parameters. Water permeability is just 9 mm. Actually, the thickness of this element is around 25 mm, in which 9 mm is the penetration depth. This is under the pressure of around 5 bar pressure for 72 hours. So once after 72 hours, we will break it. If we measure the depth of penetration of water, it's only 9 mm. So it can be better utilized.
So this is for in situ casting?
Huh?
In situ casting?
In situ casting.
For
And
precast?
one more thing, what we have to notice, it's since this fiber is a non-metallic, even if it is higher depth, permeability is more, it won't lead to corrosion. Whereas a metallic reinforcement, once it touches the concrete, then oxidation reduction reactions are taking place and leads to corrosion. Here non-metallic, that's not a criteria, but still it maintains because the paste content will be more. So that it we are achieving. And another question is, what we have done is only for the non-structural purposes, not for the structural purpose. As I said, if there is a out of plane bending, for example, if I want to make a beam by using TRC, then it will be not a good candidate because the out of plane bending is very less, thickness is less.
Right.
Whereas if we can make it as a outer formwork and fill it up with concrete, so if it is made as a hybrid with concrete and TRC, then it can be workable.
And in case of precast panels, how do you do jointing?
So jointing, what we do here, male-female joints, actually it is done for the non-structural elements only, not for structures. For structures, it is a different loop connections and all we are using. Here, it is just the grout, non-metallic, non-shrink grouts are there. Using that, we can make the porous this thing. In fact, precast, L&T has done the first tallest building in Mumbai. It's a 23-story building in Boivara. So I was there for the project, and we have done a lot of tests for the establishing the seismic adequacy of these precast joints. In the SCRC, we have done it. Today, we are extensively using all these precast connections.
Thank you, sir. We can have the further questions later before technical session. I call upon stage Dr. K. Sundaram to say a few words.
We thank Dr. Govind Raj for such a wonderful enlightening. He also covered some kg to kg basics, starting from wires, bars, cement, and the different types. Thank you very much, sir, for your presentation. Of course, अभी रोटी कपड़ा मकान हो गया, लेकिन रोटी मकान अब ये कपड़ा हो गया. So now we go. So the next question is, what is next, right? Can anybody guess what is next? रोटी कपड़ा मकान बाद में मेरा दुकान. So is the general thing which is said. This is a old Junior Mahmood statement, but with this there are different technologies which have evolved, and L&T is running the forefront, and he's heading the L&T R&D division in Chennai in the construction sector. So now we now call upon. Thank you very much, sir. You can. Yes. Thank you. We now call upon Owen Waldschagel to do the Dukan. Okay, so he's from New York and he's come all the way from New York. He's a regular attendee of the Ferrocement society, and he's come for almost every conference to the best of my knowledge, and he's here now to tell us something about what they are doing in the USA and what he's done in Mexico, and then you'll hear a lot about him. Welcome on stage, Owen. Please welcome him.
Hello. Thanks for having me here. I'll try to speak about what this man said I was going to speak about, but I had another idea. Let's see. Let's see it. Okay, here's what I want to know. Wait.
This one?
Wait,
These two?
wait. What's this say?
It says Owen
Go, no, this one.
Ferrocement, so this is presentation for Bnca FS.
What is from, I think that might be me.
This is yours, sir. These two are yours.
What is this?
It is Owen I A. open?
No, but
Intact
what is
structures.
this?
The one at the bottom, right?
Yeah, I think I may have sent that.
All right. Yeah, I copied from your pen drive.
No, besides that, I think this
Alright, I'll
was,
just open
let's
this for
just
you.
look at it, yeah.
Is this yours? No.
Okay, it's not that. Okay, then it's, go up.
It's this one only, sir.
Okay,
We
thank
copied
you,
in the morning.
thank you. I'm missing one, that's what it is. This is fine. So, how do I move mouse? Does the mouse
I'll
move?
operate it for you. You just
No,
take this
I'd rather have me do it.
Alright, no problem.
Does the mouse move it?
Yes, just a minute. You can It's moving.
No, it doesn't. Okay. It's not moving it. Oh, go back? Oh, I see, it's opposite. I got it, thank you. Thanks for waiting. This will be a synopsis of a building system called Intact Structures. It's composed of 4 components that can build genomic multiple design configurations. And they're all capable of utilizing ferrocement in ways that I have not seen yet. A couple of times I have, but not much. One way is that the system collects and stores water. Also, there's the potential of fish farms and biodynamic vegetable farms in the incorporated in the designs. So here we go. Anyway, this is a schematic of a single-family house. Pardon me?
There's a thing coming on the screen.
Yeah,
I'll ask the volunteer to close it.
no, I'll do it. Thanks. Anyway, that's the floor plan of a single-family house, which you'll see one that was built. These are the components that construct all the designs that you see. As I said, there's 3 there. There's one more, but there's 4 in total, and they do construct all these designs. That's backwards. That's actually a picture of a template of the way those pin points are the way you would fabricate it on a table. Again, these are some of the components. The one that's missing is what I call a turkey tail, which is, this is an important component. That one right there. It's 5 18-degree angles, and it creates the apex for the elliptical roof. This would be laid out on the slab so that when you constructed the building, you line the beam up with the perimeter points. As you see, there's holes in the beam for air and light, and to lighten the beam itself. It's a ferrocement beam. Going backwards. this mouse works backwards than the one I use, so it's working backwards again. There we go. Okay. This would be a wall section of what I call the elliptical design. As you can see, the components in green are the first components you saw. The beam is at the top, right there. That's the beam. You see they line up 2 points on the beam. They create the frame by the holes in the foundation. They line up with the holes in the beam. Okay. There's the structure starting to go together. There's more of it in different depictions. There's the actual building that was built in Mexico. More or less from what you just saw. The interesting part of this building is that it was built prior to these drawings. More or less, I drew it out of the rebar in Mexico. Here's a thought of it would be placed in a slum to train the people in the slum to build themselves houses that hopefully would interest them and move them more or less physically into those buildings rather than these structures. Bless you, by the way. Oh, here's the way that something I call the oasis is constructed, and I did this this way because, bless you again. I did that this way because everyone was having trouble making an AutoCAD drawing of this design. So there you go. See that? That's what I call AutoCAD, but it was made actually from a photograph of, I'll go back to this. Hold on. How come it's not moving? Oh, it's up there, that's why it's not moving. No, we're missing one. All right. Anyway, this initially was going to be a small medical center. And that's the way it would look with cultured stone on the outside. And this actually is the gutter that I'm talking about that collects and stores water. And there would be the fish farm that would be created by Ferrocement. And that would be a biodynamic farm, which by elevating it the way it's elevated in the drawing, you could place it in an area that the land was contaminated by the previous activity on the land, which happens around many slums all over the world. The land can't be farmed at all, so people can't get involved in any kind of natural occupation. What they do is they either take motorcycles apart or play video games and watch TV. You see the dishes on the roofs and everything. I think it would be better for them to function in a way that gave them food on their table. It might work, actually, if you introduce them to it. I have a feeling a lot of people that are involved in that style of existence have never been involved in other styles of existence. So they're in a trap. The screen is their life, or the motorcycle, or something like that. It's a trap. Okay. Okay, could I go to the next one? And I won't be as long as everyone else. I'm almost finished. I'm not as technical as everyone. Could you get me to the other one, please? I'm trying to get to the other.
Yes, just give me a minute.
There you go. What would be the other? Let's see the names. Let's see that one. Let's try that. Thank you. These are illustrations of what those designs could be. I haven't had the luxury of building them yet, and maybe I will or maybe I won't, but I do know what they could do. And for instance, that one design that looked like this right here could extrapolate. You just make the foundation footprint whichever way you want. And you could have, you see, also in this presentation, I think there's a retaining wall that I built that I'll show you. Anyway, that would be a retaining wall of step farming, and it would send water down to this village, say. It could be housing like garden apartments with protection areas and factories and schools, all built from the same components. This could be a small airport. Again, all built from those 4 or 5 components that I showed you. That, let's see, that could be an airport and an air terminal. Well, they're illustrations. They're actually very well done by Haejung Park, I must say, not me. Okay. There we go. Okay. That was these are the same components, and I'm not sure you can see them in a schematic, but someone asked me, could I make a Thai house? I was in Thailand, and I said, sure, and there it is. Okay, this was actually built on a roof in AIT. Unfortunately, I had a medical journey to go on when I was supposed to build it, and I wasn't exactly there after I had laid it out. But I had been to Bangkok and AIT a lot, and this was inspired by intact structures. And it's a schematic I had sent them that they could work on, but they built it. It's on